Hello, my name is Joseph Annunziata, and I'm working with Team High Five for our project SignIt, which is a sign language translation app. There are a number of items on our agenda to cover. I'll be reintroducing our team and our roles. I'm going to review the improvements that we made based off of Professor Wong's feedback. I'll do a brief overview of our project description, teamwork agreement, and personas, and I'll explain our minimal viable product. Zhou will be introducing the technology, algorithms, and architectural diagrams that we plan to base our app around. The product backlog and Sprint 2 backlog will be handled by Fariel Alam. She will also be covering the test cases and acceptance criteria. I will then come back and review the metrics for Sprint 2 and the summary of our retrospective session that we held on Friday. And Renee and she will be introducing our project demo to showcase the work that we've accomplished so far during the sprint. We did really well on our last deliverable, but we had some improvements suggested by Professor Wong. So these are the following improvements that we made. Originally, our team name was called Team Async, just because we were the asynchronous group. We had now changed that name to Team High Five. It relates more to our project as sign language gesture recognition, as well as shows that we're a functioning team. We also omitted the business analysis and monetization slides because it doesn't necessarily pertain to our project development flow. We also made changes to the timeline schedule slide, which is now the backlog. And we've itemized those in a table that's more easily legible for users watching this. I've designated some of the changes with a star at the top right corner of the slide, just to show that those slides have been changed from the past deliverable. Briefly, our problem statement regards the lack of resources for people who are hearing impaired or deaf and need to use sign language and be able to communicate with others. Additionally, the other problem is the amount of people who can hear fine, but are not capable of translating sign language for themselves or for family members. Our project description is an app that's capable of bridging the gap between those who can translate and communicate with sign language and those who cannot. And this will help both the hearing impaired community as well as those who can hear. Just a quick overview, our personas did not change. Jane is a mother of a newly adopted 12-year-old daughter, and she needs the tools for fast communication to interpret sign language quickly and efficiently in order to interact with her new daughter. Persona 2 is Simon, who is a 37-year-old project manager and is entrusted with integrating a new team member who is hearing impaired. So he needs an app that's able to translate for him and his other teammates in order to navigate workflows with Paul. And Persona 3 is Jack. Jack is a teacher and he's dedicated to teaching in an environment that includes deaf and hearing impaired children. So he sees a translation app as a great tool to be used to help other children understand sign language fast and efficiently and be able to communicate amongst the students. Our MVP is split into two parts. First is an Android application made in Android Studio. On that application, we have a login page, and that includes a field to enter email, password, and an alternative sign-in with a Google account as well, and a button to register a new profile into the app. The next page is the registration page for those new profiles. There's fields to enter email, password, and a button to complete the registration and a button to redirect to the login page. Once a user is logged in, there's a home page This is a grid-style dashboard currently with 4 buttons. The first button is to access the camera feed. The second button is a how-to guide that will be able to assist users in how to set up the environment. Button 3 is to access settings for sensitivity for the camera and the machine learning model. And the fourth button is to log out of the app. In the camera, it'll pull up a live feed view from a mobile device camera. Finally, the machine learning model currently is in a separate format. It's not integrated into the application yet, but it has been built. It is a custom machine learning model. It's trained on custom-made data set of 3 different types of hand and sign gesture expressions. It's able to distinguish between landmark poses between 2 hands, a face, and a shoulder pose. Because sign language is so expressive, we need to adhere to a large data set in order to determine gestures and poses. So ultimately, our MVP is an app that has a feature for login, registration, and a camera feed. And our machine learning model is created through a Python data set, through a Python notebook, and is able to put outputs according to the processing data that's put into it. Ultimately, our end goal is to merge the two, create some sort of way to put the machine learning model directly inside the app. We are facing one situation where we're going to implement it directly into the app, so it's all on board. There's another path we may take regarding connecting to a back-end server to feed the machine learning model data directly from the app over an internet connection, and for the model to analyze the data and send that information back to the application. Just a quick review of our team. I'm Joseph Annunziata. I'm the Scrum Master and Machine Learning Engineer. Farial Alam is the UI developer and testing engineer. Renee Irias is handling the full stack development, and he's also handling the UI development as well. Shijo is handling the backend development and also assisting with the machine learning as an engineer and model creator. Regarding our teamwork agreement, we changed some of the scheduling days. So originally we had chosen to meet on Mondays and Fridays. We changed it to Tuesdays and Fridays, just to match up with everybody's traveling schedules from over the weekend. And we've been flexible in making sure that everybody's on the calls between 5 and 6. Typically, we've been meeting at 6. But we've been flexible in getting everybody together during the time slot that we can.
So let's talk about the technologies. So based on the first deliverable, we add media pipe for gesture, face, and body key point extraction and Kotlin for Android application development. And as for the conceptual architecture diagram, the user is going to open the application and use our core feature, a core function, which will invoke the camera, and those image stream will be converted to usable data as an input to the machine learning model by OpenCV and media pipe, and the machine learning model is trained using TensorFlow. And in order to use this model on the mobile application, we're thinking about just convert this TensorFlow model to a TensorFlow Lite. As for the sequence diagram, so the user is going to open the application. The first thing the user is going to see is the starting graphical user interface and a login screen. After the login, the user can just press the button to use our core function, which will invoke the camera. And by doing that, the user should be able to see the images that the camera is capturing, and those image will be converted to the data that usable to the machine learning model and feed it to the model. After the calculation, just return the feedback, and will display the prediction result in the camera page, and so the user can get real-time feedback. So as for the machine learning part I've been working on, so I'll just import those dependencies I mentioned before, like OpenCV and MediaPipe. Then these functions is trying to apply these landmarks or key points when the camera is invoked. So now I tried connection to the camera and the media pipe. So I cannot invoke camera again because I'm using this camera to record, but this is the result we're getting. To be honest, looks pretty good. And I just extract all those key points you see here, and I convert them to a giant NumPy array so we can work on. Oh, and at this point, I'm setting up this folder for data collection. This is the collecting key point sequence part, and in this code block, I invoke the camera, and to record the videos I'm going to use to train the models. So this is the part where I process the data and create. This is the part where I just collect all those data, and after that, I create a label map. And at this point of time, we only detect 3 moves. It's just hello, thanks, and I love you. So this is the part I process data and create labels. So next thing is to create the model and actually train the model. So I apply 3 layers of LSTM model and the 3 layers of dense model. So after the training of the data, we have this model saved, and after the model is trained, what it returns is eventually an array of size of 3, because remember we only detect 3 moves. The rest here is array size of 3 with decimal numbers. All those decimal numbers add up together will be equal to 1, which means those decimal numbers is the possibility of each movement. So here I have the prediction in the variable res, and I have the test data in the y-test. So we can see here what we get here is I love you, and in the test data it's also I love you, which means the model is actually working. So this is the part is make the sign language prediction. Then I save the model to the TF format at the current time. So this is the save model and waits parts. So as for the evaluation part, I'm still working on that. So this is basically the machine learning part I've been working on, and the bottom line is we have a working model already. So next step, I'm thinking about increased accuracy and maybe add more actions that the model can detect. So yeah, this is the machine learning part.
Hello, my name is Faryal Alam. I am the UI developer and the testing engineer of our group, and I will be going over our product backlog with you, some completed stories and tasks for Sprint 2, as well as some of the user stories that are not yet completed. And I will also be talking about our acceptance criteria and our test cases. So let's get started with our product backlog. As you can see over here, this slide presents our current product backlog for the app. It details the key user stories we're focusing on to enhance the overall user experience. It highlights our progress across various features that includes login capabilities, password recovery, gesture analysis, and much more, which shows a mix of completed and in progress items that are mapped to the respective areas within the app. You can see that over here in the status column, it either says completed or in progress, and as well as their respective areas that you can find within the app. Let's talk about the completed stories and the tasks so far that we have. So the slide here provides basically a formal summary of the completed tasks in Sprint 2 for our app. And here we have successfully implemented key user features such as various login methods and continuous camera functionality for live gesture translations, which are again all part of making the app smoother and more user-friendlier. Let's talk a little bit about these user stories that are not yet completed. We are currently in progress and working on them. And this includes features such as password recovery, gesture analysis, and sign language translation. Each story is actively worked upon with a focus on enhancing user interaction and the app's overall functionality, which leads me now to our acceptance criteria. So in total, we have 6 different scenarios for the acceptance criteria. Let's say a user wants to access an app for sign language translation. The criteria for that must be that the app must offer a sign language translation service that is not only accurate but also real time, which enables the user to communicate without the need for a paid translator. Similarly, if a user wants to log into the app via a traditional route, that means using a username and password, the system must securely handle the login process with encryption and provide access only upon successful authentication. Our next scenario talks about password recovery. That is in the case if, let's say, the user were to forget their password, then the app must provide a secure and user-friendly process for password recovery and reset. Number 4 talks about granting camera permission for live translation feature. So here, I just want to go over with you guys what we exactly mean by that. Given I am a user who needs to translate the live sign language, when I select the live translation feature on the SignIt app, it should be I should be prompted to grant camera permissions, and I accept and grant camera access to the app. Then I should be able to use the live translation feature to translate sign language in real time. Again, the criteria for this scenario to be true is that the app must request and obtain user permission to access the camera for the live translation feature to function properly. That ensures the user's privacy and a seamless operation of the app. Which leads me to our last 2 scenarios. It talks about accessing the app from multiple devices and recognizing common sign language gestures. Now, if you want to access our app via multiple or different devices, then the app must support multi-device access. It should allow users to seamlessly transition between devices and retain full functionality without repetitive setup processes. Similarly, for the recognizing common sign language gestures, the machine learning model that we have so far should be able to quickly recognize common sign language expressions and display accurate translations on the screen. This concludes our acceptance criteria, which leads me now to our test cases. So here we have test case TC0001. This test case is basically to verify user login with valid credentials. Now we have 2 separate login methods, one the traditional login process and the other one being the login with the Google process. And we have performed both of these functionalities and have marked them as pass in this test because the app successfully authenticated the user's credentials and navigated the user to the home screen, which is also what the expected result was for this test case. Now, our last test case for now is the TC0002. This test case is mainly focused on our testing the machine learning model, excuse me, that we have so far. Here, the steps included opening the Python notebook containing the model and the training source code. We are running different cells to generate the model. We are running the cell in sequence in order to generate the training and the testing data. And what we're expecting is that the model outputs the correct label for the gesture data that was submitted. In this case, the gesture data that we're using is the hello gesture. And as a result, the model output the label for the hello gesture, and it matches the data that was submitted. Therefore, we are again marking this test case as pass, and there are again no additional notes that would be that would be added in case something would be noticed as unusual behavior. And the post condition for this is that after executing the test case, the machine learning model remains in its trained state, ready for integration without altering its performance or the integrity of the test data set. This concludes my presentation. Thank you for your time.
As you can see here, these are the metrics for Sprint 2 for our team. This is the team velocity chart of tasks that we're committed to doing and tasks that were completed. Next is the Sprint 2 burn down chart. These are the tasks completed versus the tasks that we would plan to commit to and complete versus the tasks that we actually did complete. Unfortunately, with timing, we weren't able to get to all the tasks that we had committed to, but we did definitely succeed in getting that number of tasks down to a minimum. And this is the completed to committed ratio. We had 6 stories that we had committed to completing this during the sprint. 4 of those stories were completed, so the ratio is 66.66%. We recorded our retrospective session on Friday, March 8th. So what went well during the retrospective and this past sprint. So participation in all aspects of the project was really good. The set action items that we had listed from the Sprint 1 retrospective were worked on and were met for the sprint. We also had very fast decision-making exercises that we performed with certain tasks related to the project. And we also helped each other and assisted each other with different aspects of the project for those who needed more assistance. Regarding what can be improved, focus the meetings on putting all parts of the project together instead of having it being disjointed in individual tasks. Meeting attendance is something that we're trying to improve upon as well. Sometimes people's schedules, work conflicts can interfere with our meeting schedules. So giving people a heads up notice during that time if they can't make that meeting. If not, we'll schedule follow-up calls just to recap. More in-depth collaboration between team members for work that needs to be connected, specifically the integration between the machine learning model and the Android Studio app, as well as the UI for the app and the functionality of the front end code. Additionally, reducing call meeting times. Most likely between 30 and 40 minutes should be sufficient, but we've been running over an hour for some of the calls, and some of the calls focus on other tasks that 1 or 2 members are working on versus the other 2. So they don't need to be in on those calls. So just helping out with everybody's schedules. Regarding the action items, we've decided to set time limits for our weekly calls on Tuesdays and Fridays to be had between 30 to 40 minutes, just to allow for everybody to express what they're working on specifically, and not to go too overboard with discussing certain tasks that other members aren't on board for. We also want to create a priority list for tasks and app functionalities instead of having loosely disjointed functionalities for certain aspects of our app, to focus on what priorities we should be focusing on for the current sprint. And if we get those tasks done on time, then we can focus on improving and adding more functionalities. But setting up a priority list for that. We also want to open the line of communication between team members more. We're not specifically trying to get everybody to be on Discord 24/7, but we do want open lines of communication. Check Discord a couple hours for a couple hours during the day, just to see if anybody needs anything. and always just try to help and respond within 24 to 48 hours. Additionally, setting up individual meetings with team members who are collaborating on tasks that each individual member is working on. It's a lot easier and convenient to set up an individual call with one person versus a call with 4 of us. So if there's specific issues that you're having with some of the tasks involved in creating this app, we've decided that it's easier to set up individual calls with somebody who can help you with instead of dedicating time in the weekly calls. After reviewing the stories and tasks that were not completed, we decided to keep these tasks and stories for Sprint 3. So for Sprint 3, we want to be able to log out of the app. We want to be able to reset the password in case a user forgot one. We want to be able to open the the phone's camera and analyze gestures on the fly, basically implementing our full machine learning model into the app. So tasks involved in that is integrating the logout function within Android Studio, also integrating password recovery capabilities, general updating of the UI framework, especially for the camera part, in terms of putting landmark lines showing hand palms and fingers so that a user can see that it's recognizing hand as an overlay. And the final integration of the machine learning model in Android Studio.
Hi, hello, my name is Rene Diaz. I'm the full stack developer and I will be introducing a little bit of our app structure. Basically, our app aims to facilitate communication for the hearing impaired community through intuitive features and user-friendly design. An overview of our app is that our interface comprises 4 card buttons and an additional button for accessing the camera. Each card button serves a distinct function, enhancing user experience and accessibility. The first one is the Camera Live Feed screen. The Camera Live Feed screen displays real-time translation of hand sign gestures into English. Users can interact with the app by performing sign language gestures, and the app provides instantaneous translations for improved communication. We also had included a guide. The how-to guide section offers valuable tips and resources for effectively using the app. Users can access step-by-step instructions, tutorials, and troubleshooting tips to optimize their experience with the app. The settings screen allows the user to customize their app experience according to their preferences. They can adjust settings such as gesture recognition sensitivity and notification preferences to tailor the app to their needs. Next, we have the app login and sign up page. The registration page screen allows users to create an account with SignIt by providing their email and password. Users can easily register and gain access to sign its features and services. The login screen offers 2 convenience methods for accessing SignIt. Users can log in using their Google account or by entering their email and password directly into the app. This dual login approach ensures flexibility and ease of access for all of the users. As you can see here, you can see the main page, which contains the 4 buttons: the camera, how-to guide, settings, and the logout button. The next screenshot is the login screen, and the other one is the sign up screen. Here is the login database where all of our user data will be stored. And in here you can see you can play the live demo of our app.
And this is a quick demo of our app so far.